Hi, well, we've been doing stuff with finding inverses of different kind of functions, power functions, linear functions, irrational functions, logs, exponents. Now we're going to do something that is going to be taking one of the functions that we have, and we're going to find it's going to have a restricted domain of what you're doing. For example, if I said f of x is equal to 5x minus 1 for x is greater than 6. And I want to find the inverse of this function. Well, if I think graphically about how this problem is going to work, in doing that, I know I would have 1, 2, 3, 4, 5, 6. Of course, I get something. I know that I'm going to have something that's going to start way up here, and I'm only going to have part of that graph. I'm not going to have the entire graph that I would have. So I can still do the problem the way I started. Switch your x and your y. So 5y minus 1. I would add 1. And then I divide that by 5. So I would get f inverse of x is equal to, say, 1/5 x minus 1. But because this is restricted, you remember we start with a domain, which we said was x is greater than 6. And the range, we don't know, but I need that because in this problem, I'm going to have to know the range of this one to find the domain of that one. So when I input 6, I get 6 times 5 is 30 minus 1, which is 29. So y is greater than 29. So I need to write for x is greater than 29. So I need to make sure that my restriction from the beginning of this problem is actually part of what we need to do when we're working the problem. So if this part is restricted, we're not looking at a whole graph. We're only looking at part of that graph whenever you are doing it. Now let's say I've got something like f of x is equal to negative 3x plus 7 for x is less than or equal to 5. Okay, so again, if we think about what this graph looks like, we would have something that would be putting in 5, negative 15 plus 7 is negative 8. So that would be here. If we put in 4, negative 12 plus 5 gives me negative 5. If I put in 0, I get 7. So I have a graph that looks like this. So x is getting smaller, but this is a negative graph, so y is getting larger. So when the domain of this is x is less than or equal to 5, the range of this is going to be y is greater than or equal to negative 8. So I put in my problem, and I would say, okay, x is equal to negative 3y plus 7, subtract 7, and divide by negative 3. So f inverse of x is equal to negative 1/3 x minus 7. And I need now to put this inside. Y is greater than or equal to negative 8. So it becomes very important as you're running through the problems that you have here that you think about what the graphs look like, and you think about how I'm going to get my ranges, because in an inverse, a range is just as important as the domain is when you're working on. All right, let's say we have something like f of x is equal to x squared minus 5. For x is greater than 3. Okay. Working this one, I can find my domain. So my domain was given. So my domain is x is greater than 3. My range, I'm going to plug it in. 9 minus 5 is 4. If I put in 4, 60 minus 5 is 9. So I can see that y is greater than 4. Okay, so finding my inverse, I would have x is equal to y squared minus 5. X plus 5 is equal to y squared. Square root that, and I got y inverse is equal to plus or minus the square root of x minus 5. And you might say, okay, but y is greater than 4. I mean, for x is greater than 4. Whoops, that should be a plus 5. So x is greater than 4. And while that looks like a good answer, again, we need to think about what this looks like. Okay. So I know that this graph starts at -5. So 1, 2, 3, 4, 5. And I know that in theory, this graph is going to look like this. And I would say 1, 2, 3. So I know that really my graph is going to start somewhere here and it's going to go like that. Okay, so not on this part of my graph. I'm on the positive part of my graph. And if I look at the inverse of this problem, so 1, 2, 3, 4, 5. So this would have started back here, and it would have looked like this, and it would have looked like this. And I need for x to be greater than 4, so I need the part that comes up here, not the part that comes down here. So this time, plus or minus is not important in my answer. I need to choose which one of those it might be. So I would say, I can say f inverse of x is equal to the square root of x plus 5 for x is greater than 4. So that would be the inverse answer that I need for that. Okay, I need the part that comes up here where the y is greater than 4, not the one that comes down here. So if I wanted to say, see the other piece of that function, let's say we kept that one and we said f of x is equal to x squared minus 5 for x is less than -1. Okay, still have the same graph. So -1 would be 1, so -1, so here is -4. So this graph then would look like this. And the part of my graph that I can use is the part that comes right here, okay? So this says I've got the point -1, -4. Just like this one has the point +3, +4. Okay, so now if I do the problem, I'm going to, we're going to say change x and y. So x is equal to y squared minus 5. X plus 5 equals y squared. Square root both parts. And you get y is equal to plus or minus the square root of x plus 5 for x is greater than -4. Okay, so when you look at the inverse of this graph, so I would have the point -4, -1, which would be here, but you know by looking at this that the point -4, +4 would also be on that graph. So you would have this, right? And I need the point -1, -4, or the point 4, -1. So I need this graph, which is on the bottom section of this graph. So instead of using plus or minus, This time we only need minus negative square root of x plus 5 for x is greater than negative 4. And that would be the inverse of our problem when we're doing that. Again, you have to look graphically sometimes and think about what your problem looks like before you try doing something else when you're working through what you have. Okay, let's say we have something like f of x is equal to, is equal to 4x, 4x is greater than 2. And f of x is equal to 2x plus 1, for x is less than or equal to 2. So this time we have a piecewise function. So if I think about what this looks like, the first piece of this would be when x is 0, y is 0. Oops. So over 1 of 1, 2, 3, 4. Over 1 of 1, 2, 3, 4. So I know that if I input 2, I have the point here that would be 2, 8. Okay. So then I would have this piece of my graph. So when x is 2, y is equal to 8. So this would be y is greater than or equal to 8 for the range. And this one, you would look and go, well, if I put 2 in here, I would have 2 plus 1 is 5. So I would have 2 positive 5. If I put in 1, I get 3. If I put in 0, I get 1. So this time I have a graph that looks like this. And that would be a function because this would be, this is a function, so we can do that. So now I've got to do 2 parts of this one. So this one has a range of y is less than or equal to 5. Okay, so now I have to find 2 different inverses. X is equal to 4y. So 1/4 x is equal to y. So that would give me y inverse is equal to 1/4 x for x is greater than or equal to 8. On the next piece of this, I would have y inverse. So x is equal to 2y plus 1. X minus 1 is equal to 2y. Then x minus 1 divided by 2 is equal to y inverse. And then I would need to restrict this one to x is less than or equal to 5. And I could put it this time so I would just have 2 separate equations. So f inverse of x is equal to 1/4 x for x is greater than or equal to 8. And x minus 1 over 2 for x is less than or equal to 5. You need to be careful. Whoa, that's bad. Be careful with a piecewise function. Do the domains intersect? And the answer is no for this one. But if you had had this, if you had had f inverse of x is equal to, say, x plus 3 for x is less than 15, and 2x plus 1 for x is greater than or equal to 12. These domains cross, so the inverse is not a function. Okay, and that's really all there is to this. Just make sure you find the range of the restricted domain and input that in your answer. So then you want to make sure that you are, so watch out for plus or minus, because it's not going to be both if it's restricted. And be careful with piecewise. Okay, and that's pretty much all that we have to it. You have a nice short little lesson of homework of 8 questions. So hopefully that helps you be a little bit clear in what you need to do. You guys have a good afternoon.